In this instructional video, I will be showing you how to install a solar panel for Puget Sound Energy customers. The first thing is planning. You're going to have to think about how many panels you want, how much you want to spend, and how much energy you want to offset. It's easy to calculate how much energy you use by just looking at your Puget Sound Energy bill. You can use that figure to estimate how much energy you want to offset. In terms of cost, expect between $6 and $8 a watt. My panel is about 200 to 250 watts, and the system costs about $1,500. So that's about $8 a watt, which is average. You're going to need materials. The first and most obvious is a solar panel. As you can see, underneath the solar panel is a microinverter, that silver box, made by Enphase. You're going to want that if you're installing a small system like I did. You also need conduit, the gray tubing, a rack, which the panel's sitting on, roof mounts the rack is sitting on. Inside the conduit, you need wires. And you're going to want THHN or THWN wires. You don't want to use UF cables. If you get a copy of the National Electric Codes, which I suggest you do, it specifies that you can use UF cables if you desire, but there are a lot of rules that only apply to those that are pretty difficult to follow in terms of how you maneuver it through conduit and whatnot. So just use THHN wire. Comes in all sorts of gauges and colors, and you will be set. So I'll also make a note about the conduit. So the code specifies that you need to have a pull point or relieving point, such as this conduit body, at least every 360 degrees or 4 bends in the conduit, 490-degree bends. So as you can see, there's the end of the conduit. There's one bend, pull point, 1 bend, 2 bends, 3 bends, and at the bottom there's a pull point. So make sure you have those, or your electrical system will not be approved and you'll have to go back and re-pull all the conduit, or all the wiring through the conduit. You also need to support your conduit with these straps at least every 3 feet to have it approved. Another thing I'll touch on later is warning signs. You need to have warning signs all over the place. And all of the specifics can be found in the National Electric Codes. Other materials you're going to need are a AC disconnect with an on-off switch that is lockable, and a meter base. The meter base is to plug a production meter into for PSE, so you can measure how much energy you're producing. This is a net meter. This is your current meter at the house, and it measures the total energy usage. You're also going to need a breaker. A double pole breaker just like this one, and so this line 1 and line 2 come in from the panel, and this is how you actually tie in the panel to your household energy system. Now that you're familiar with materials, let's talk a little bit about more of what you need. You're going to need an electrical permit, a building permit, and you will absolutely need to contact your Puget Sound Energy representative to let them know what you're up to. I recommend looking up some resources online to help you figure out how much you want to offset and how many panels you need. A good website is Find Solar. Just look that up, and there's a solar calculator, and it'll tell you how many panels you need and how much the estimated cost of your system will be to offset however much energy you want. You also need to make sure you have permission to install your panel. Make sure your neighborhood committee knows that you're installing a panel. In some places they don't like you installing panels on your roofs because it damages the visual appeal of the neighborhood. Luckily in my case that wasn't the case. Also call your roofer to make sure that they know you're drilling into the roof, because sometimes if you drill holes and you get a leak, your roofer will not let you make a claim on the warranty because you've damaged the roof yourself. I recommend getting to know an installer of solar panels and your local electrical inspector. They can be very helpful when you get stuck. Once you have all the materials and permits you need, you're ready to start installing. First, you're going to want to put the roof mounts down. That's that black thing you see. You're going to want to drill these into the rafters, and to do that you can get a stud finder, or, since sometimes that's difficult on a shingled roof, you can look underneath the overhang below. I can't show you now, but you can see the rafter goes down there, and you can make a chalk line up to mark where the rafters would be to drill into those. If you don't drill into those, you risk drilling a lag bolt just through plywood, and that won't get a good hold. It's also very important to make sure you're using the right size lag bolts. My building inspector told me that I needed to have a specific size of lag bolt, so I got one that's a little bit bigger just in case. Let's talk about the rack a little bit. As you can see, my rack is made of slotted angle iron that I built myself. And in doing so, I discovered that it probably would have been more cost effective to just buy a professional solar panel rack. You can get them online or at a retailer for relatively cheap. This rack cost me about $75 in raw materials, which I wasn't anticipating. So if I were you, I would buy a professional rack for aesthetic and economic reasons. Now, once you have your rack in place, you need to run your conduit. So my conduit is, I think, 3/4 inches, and you definitely want to get the right size or right width of conduit and the right type of conduit. Don't buy any white PVC piping, because any National Electric codes won't let you use that. Once your conduit's all laid out, you need to glue it. You need to seal the conduit so that no water gets in there and damages the wires. Once the glue is dried, you need to pull wire through it. You can get a conduit puller. It's a thin piece of metal. Put that through your conduit, and then at the end there's a hook. You're going to wrap your wires around that hook and then pull it all the way through the conduit to these pull points. And once you have it pulled, you want to seal the ends. So you can get this, I'm not sure what it's called, but it has a rubber fitting, and you need to seal the ends of your conduit with that. Once the wires have been pulled through the conduit, it's time to wire the AC disconnect and the production meter base. Coming from your panel, you should have 4 wires: your neutral, ground, line 1, and line 2. The line 1 and line 2 need to come up to the top of the AC disconnect and plug in to the 2 different sides of the terminals. On the other ends, the load side, you connect them and then go into the meter base. And unfortunately, I just got this meter installed, so I can't show you that, but it looks the same. The wires come up to the top, into the 2 lugs, you attach them, and then from the bottom, you take the load wires and you go through the wall and into your breaker. Now, the neutral and ground wires just go straight through these and into the breaker box. The ground wire, you have to ground to every metal component, so you need to ground out to the disconnect and to the back of the meter base. Inside the breaker panel, you take your 4 wires and you run the neutral to the neutral lug, the ground to the grounding bus, and the line and load, or the line 1 and line 2 rather, you connect to the 2 poles of your double pole breaker. The next step is to have everything inspected. Once again, make sure you've adhered to the National Electric codes, and if you have one, go through your inspector's checklist. A hint is that if it looks tidy, an inspector will like it. Once inspections have been passed, you have to fill out a few forms for Puget Sound Energy. The most important is Schedule 150. That's the application for interconnection. Once you've filled that up and alerted Puget Sound Energy that your system's ready to complete it, you throw the breaker from off to on and energize the meter base. Once that's ready, Puget Sound Energy will conduct a series of tests on your system to make sure that it's all wired correctly. Then they'll install the new meters and your system's ready to go.